Hey, it's Mr. N, and we're going to do the Chapter 4 in-class geometry review right now. So for this first problem, okay, we're going to use translations. And it says, use the translation TXY such that x minus 3, y plus 1. So that's my translation. And this other translation is, it's not, it should say transformations. Let's clarify. Transformations. Because this right here, since I'm multiplying, is a dilation, right? So on this first one, it says we're going to use t for the point, this transformation for the point negative 2, 5. So what I want to do is I'm going to put in negative 2 minus 3. And then in this case, it'll be 5 plus 1. So I put in the x right here. To the x right there, I put in the y right there to the y right there. So this new point comes out to be negative 5, 6. For the next one, same thing. Put in the x and put in the y. So this new point ends up being 6, negative 3. Now for the pre-image, what we're doing on these pre-image ones is this is where I ended up. So I want to know what happened before it. So I'm going to do the opposite under this transformation. So instead of subtracting 3, I'm going to add 3. So this was 6. So it went from 6 to 3. So this was the point that came before. So in other words, this time it's saying I want to go backwards. I know the t prime. I want to know what t was. And then over here, instead of adding 1, I'm going to subtract 1, so I'll get negative 3. Again, if you put this point into that transformation, you will end up with 3, negative 2. Okay, for number 2, it says use the figure to complete each statement. List all answers as the new letter. So right here, it asks me to reflect about the x-axis, point A. Right there becomes what? Well, if I reflect about the x-axis, point A becomes point D. For the next one, it says reflect about the y-axis. So I'm going to reflect about the y-axis. So here's point D. And if I go about the y-axis, I end up at point C. The next one asks me to do this transformation. X minus 1, y minus 3. So I'm going to use B and find out where that ends up. So if here's point B, I'm going to go x minus 1. So I'm going to go back 1, and then y minus 3, 1, 2, 3, down 3. I end up at point P. Okay, the next question is a rotation. For D, we are rotating about the origin, right there. And point C, by a 90-degree rotation, where does this end up? Well, if I rotate 90 degrees, this is a right angle right there. Okay, so if I rotate 90 degrees, I'll end up at point B. And then we are going to reflect about J for part E. So for part E, I've got this line J. I have too much drawn in here, so you may not be able to see it well. So I've got this line J. That's my line. And I want to reflect point A about line J. Well, from point A to J, I need to make it perpendicular, so I went over 2, down 2. That's right there, perpendicular to it. So do the opposite. Go down 2, over 2 this way, and I'll end up at point C. So this reflected, if I fold this over, so if I fold over A, make that fold, it'll end up where C is, right over there. Okay, now number 3. It says, use the transformation TXY goes to, maps to, x minus 2, y plus 1, and the point 2, 4, and the origin O with the line L. So if you can't see this, this is line L right there. With the equation y equals x. So y equals x is this line L. To answer each, you can use the graph to help. Now, these are composites, and these are all composites because I've got 2 things going on. So whenever I have a composite, such as this one, reflection x of reflection y. We always work inside to out. So I will do this one first and then do this one second. It's like having the order of operations where you would do inside the parentheses first. So that's how we're going to do these problems. So for the first one, I'm asked to reflect this point about y. So 2, 4, 1, 2, 1, 2, 3, 4. So this is the point P, and I'm going to reflect it about the y-axis. So this is my y-axis. So since I'm going a distance of 2 from it, I can go a distance of 2 from it the other way. This will be my point P prime. And now I have to do the second part. The second part says reflect about the x-axis. So here's the x-axis. This distance is 1, 2, 3, 4. So I'm going to go 1, 2, 3, 4 down. That would be my P double prime point. And now I can list the coordinate as negative 2, 1, 2, 3, 4, negative 4. There is another way you could have done this. We've learned that if you reflect about the y-axis, the xy point becomes negative x comma y. We take the opposite of the x value. And if you reflect about the x-axis, my xy point changes to be x negative y. So if I did this as a two-step process, and I'll do this one on the side over here using this method, I can say 2, 4. First I reflected about the y, so that became negative 2, 4. Then I reflected this one about the x, so now about the x I changed the y value, so negative 2, negative 4. So I could have done it straight up that way without having to use the grid. Okay, for part B, we've got first a reflection right here. Let me see if it'll let me erase what I already have there. Nope, and it won't. That's okay. So I have got a reflection of the point 5, 1, 1, 2, 3, 4, 5, 1 right there about the x-axis, and then I need to do this transformation to it. So first let's reflect this about the x-axis. So it ends up, so if this is my point, we'll call this one P this time. Reflecting about the x-axis will give me this new point P prime. So I went this way and the other direction. So the first step gave me P prime, which is 5, negative 1. And then I did the second step to it, this transformation. So now I'm going to say 5 minus 2 gives me 3. And then negative 1 plus 1 gives me 0. So again, this was the reflection about the x, then the transformation. So I took this point back 2 in the x and up 1 in the y, and there's my P double prime point. All right, now moving on to part C. For part C, it says reflect about the y. So first we will go ahead and do this y reflection, and then we have a rotation about point P. So let's do the y reflection first. So I've got the point 1, negative 1. So 1, negative 1 is right here. This time I'll just call this one x. And I need to reflect about the y, so that ends up going this direction. So there's my x prime. But then I'm going to rotate it. So now x prime, let's indicate what this point is. This point is at negative, x prime is at negative 1. Negative 1. And now I want to do this rotation about point P. So here's point P. And I want to do, oh, it didn't indicate here. We should say rotation about point P. Let me clarify that by 180 degrees. That should have said 180 degrees right there. We need to know how much to rotate it. We can't just rotate it about point P randomly. So we needed a 180 degree rotation. So we can take a look at where we are from point P, and from point P, I'm up 1, 2, 3, 4, 5 over 1, 2, 3. So I'm going to do this the other way. 1, 2, 3, 1, 2, 3, 4, 5. So this is where I will end up for my x double prime. So x double prime ends up right there. And this is the coordinate 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So x double prime ends up at 5, 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, moving on to part D, we have a reflection about line L and then a reflection about the Y. So here's line L, and we said if we have a reflection about a line, y equals x, for x comma y, this ends up being, so we switch these. So if I'm at negative 2, 1, 2, 3, we'll call this one W this time. And then here's line L. I went 2 and 3. I'm going to go 2 and 1, 2, 3 this way. So it's like switching it around. So we end up with this point W prime. So this becomes 2. No, that's, so for here, what we wanted to do is I needed to go over 3 and down 2. Sorry about that. So I needed to go over 3, down 2, because we switched the x and y. So this gives me the point 3, negative 2. That's my W prime. And now I need to reflect about the y. So I'm flipping this over the y-axis. So this distance is 1, 2, 3. So we're going to go 1, 2, 3 the other way. So this ends up being at negative 1, 2, 3, negative 2. So negative 3, negative 2 is my W double prime, which is that new coordinate after the composite. Okay, moving on to the next one. Number 4, use the given translations. S is that, T is that, and the points A, B, and C to answer each. List each answer as a coordinate. So for this first one, I'm given point A, and I need to do S to it right here. So I have negative 2 plus 2. So that gives me 0. And then I've got 4 minus 3, which gives me 1. For B, I need to do the T transformation to it. So this becomes 3 minus 2 gives me 1, and then negative 2 plus 1 gives me negative 1. For the next one, I need to do point C. So for point C, I end up with negative 2, and I need to do the T transformation to it. Negative 2 minus 2 is going to yield negative 4, and then 0 plus 1 is 1. And then finally, I've got a composite right here, composition. So I need to do the T first, inside out, xy, the transformation xy. Well, I'm not given a coordinate to work with. So this transformation xy is just x minus 2, y plus 1. And now I need to do the S transformation. So now I'm going to work with the S transformation, which is x plus 2, y minus 3. So what I'm going to do is this goes into the x right there. This will go into the y right there. So I have x minus 2 plus 2, comma, y plus 1 minus 3. Now let's clean that up. This ends up just being x. Over here, I can say plus 1 minus 3, which will be y minus 2. So this is doing both these transformations. So this is like me saying, okay, first move to the left 2, then up 1. After you're done doing that, move to the right 2, and then down 3. So you're doing 2 things here. Okay, moving on to number 5. For number 5, these are dilations about the origin. So A ends up being, we can just multiply it by our scale factor of 1/2. So A ends up being negative 2 times 1/2 is negative 1, and then 1 times 1/2 is 1/2. That's my new coordinate. For B, the dilation is negative 3. The negative tells us we're going to go in the opposite direction from the origin. So here I could just multiply them to get my B prime point. So B ends up being negative 3 times 2 is negative 6, and negative 3 times negative 4 is 12. Okay, for part C, what is the reflection of B around the x-axis? So when we go around the x-axis, right there, we're changing the y value. So B prime would end up being 2, 4. What is the reflection about the y-axis? So when I go around the y-axis, we're going that way, I would change the x value. So A would end up being at 2, 1. Okay, around the line y equals x, I switch the x and y. So for this one, I need point A, so it'd be 1, negative 2. Okay, moving on to number 6. So for number 6, it says, write a rule for the following transformation. Now, I'm going to tell you that this is a translation. On the test tomorrow, I indicated a translation. That way, to make sure we're all consistent so that we don't, because there could be more than one way. So I want to just make it consistent. So for this one, here's A, there's A prime. So I went 1, 2, 3, 4, 5, 6, 7, 8. 8 to the right. So this is a transformation so that every xy point goes x plus 8, because I went 8 to the right. And then I went down 1, 2, 3. So y minus 3. If you check and test the B point, we went 1, 2, 3, 4, 5, 6, 7, 8, down 1, 2, 3. It's the same thing. All of these are to the right 8, down 3. So the way I write it is x plus 8, y minus 3. Okay, moving on to the next page. So, on this page, we have to plot each polygon and then reflect in the given line. So let's go ahead and start with this first polygon. A is at 2, 1, 2, 3, 4. There's point A. Point B is going to be at negative 1, 1, 2, 3. There's point B. And point C is 3, 1, 2, 3, negative 1, 2. Right there, there's point C. So I've got this polygon. In this case, I've got a triangle. And I'm going to reflect it about the line x equals 1. The line x equals 1 is right there. That's the line in green. That's x equals 1. So I need to find the distances. That distance is 1, so I'm going to go 1 the other way. There's A prime. The distance here for B, this distance is 1, 2 from my x line. So I need to go 1, 2. And that's going to end up being B prime right there. And then C is a distance of 1, 2. So I'm going to go the other way. 1, 2. Because that's my reflection, and that's going to end up being C prime right there. So my new polygon, I will do it in another color. Let's do it in this purple color. So A prime is right there, B prime is right there, C prime is right there. I can connect them, and that's my reflection. So look at where the blue one was. That's the original. I'll darken it in, and we reflected it about a line, and that line happens to go through it, and that's okay. You could still do that. It just flips it the other way. Moving on to the second one. Let's put these points on here. D is at 1, 2. E is at 3, 1, 2, 3, 1, 2, 3, 4. F is at 2, negative 1. And then G is at negative 3, 1, 2, 3, negative 1. This is G. So I've got this polygon in here, kind of a crazy shape to it, like that. Okay, and now this time I'm going to reflect it about the line y equals negative 1. This is the line y equals negative 1. What's interesting is that GF won't change. If I flip them and they're on that line, they're not going to change. So this becomes, let's do it in another color, this becomes G prime and F prime. This one will change. This distance is 1, 2, 3, 4, 5, so we'll go 1, 2, 3, 1, 2, 3, 4, 5 the other way. This is E prime. This distance is 1, 2, 3, so we'll go 1, 2, 3 the other way, and that's my D prime. So this ends up looking like this. So all it did was flip it about this line, which was y equals negative 1. So for part D, it says use points A, B, and C to rotate 180 degrees. So when we said 180 degrees about the origin, if we had a point x, y, that ends up being negative x, negative y is what we said. Okay, so A, B, and C. So A prime, I'm gonna say negative x, negative y, so this becomes negative 2, negative 4. So then for B prime, negative x, negative y becomes, for B prime, negative x, negative y becomes 1, negative 3, and for C prime, we do the same thing. We end up with negative 3, 2. For 90 degrees about the origin, for 90 degrees, we said if we had a point x, y, that ends up being negative y, x. That's our 90-degree rotation. So for points, oh, this should have said, fine, we'll do A, B, and C. This should have said D, E, and F, but that's okay. For point A, ends up being negative 4, 2. That's A prime. B prime ends up being negative 3, negative 1. And C prime ends up being 2, 3. And we could do the D prime. The D prime ends up being negative 2, 1. Okay. Here we go with number 8, and number 8 is our last one here. And it says plot the following points, x, y, and z, and now plot x, y, or x prime, y prime, and z prime after this dilation. So let's start with negative 2, 4, 1, 2, 3, 4 right there. There is my point x. 1, 3, 1, 1, 2, 3. There is my point y. And then 1, negative 1, 2, 3, 4. There is my point z. So basically I have this triangle in here. And now I'm going to dilate about the origin by negative 2. Well, you can quickly find these x, y, and z points without having to do anything on the grid right now. Because I know that all I got to do since I'm going about the origin is multiply every x and y value by negative 2. And so let's just do that. So negative 2 times this negative 2 gives me positive 4. And then times this 4 gives me negative 8. Negative 2 times that 1 gives me the negative 2, and then times the negative 2 times the 3 gives me negative 6. And then we can say negative 2 times 1 here gives me negative 2, and negative 2 times that negative 4 gives me 8. So now we can go ahead and plot these points. So we've got 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, negative 8. Then we've got negative 2, 1, 2, negative 8. 1, negative 6, 1, 2, 3, 4, 5, 6. And then we've got negative 2, 8. So that's negative 2, 1, 2, 3, 4, 5, 6, 7, 8 right up here. So now I can connect these points. So this was my x, oops, let's fix what we did there. Okay, so now this is my x prime right here. I'm just going to label these real quick, y prime, and this was z prime, and I can connect these points, and I end up with this sort of shape, and this is my triangle after I've dilated about the origin by a scale factor of -2. So the negative told me everything went in the opposite direction, so think of it as this distance to the y point right here from the origin went in the opposite direction, twice as large. This distance to the z went twice as large in the opposite, and then this distance right from here to the x went in the opposite, twice as large. All right, hope this review helped, and good luck for your test.